5.1 is about angles, and you can't do trigonometry if you don't know basics about angles. Now, to be totally honest with you, some of the topics in here we won't need after this lesson, okay? And maybe most of you may never ever need it the rest of your life. But as far as trigonometry goes, if you're majoring in college in medical professions, you will never need trigonometry. If you are doing business, you probably won't need trigonometry. Trigonometry is very important for calculus, but there are college classes now where it's like calculus for the medical professions, calculus for business. And trust me, they don't do any trig in there because it's not needed. They just need more algebra based because most of the equations that come up in the medical world or the business world are algebraic based. So you're going to get exposed to something that if I don't teach this stuff to you, you may never, ever be exposed to it ever again. So at least you can look at it as, well, we're going to see something that once in a lifetime opportunity for you to be exposed to it. I get it that we're all not going to be math majors or engineers, but you never know about your future. Some of you guys will change paths. It just happened to us all. I didn't really change careers. Just I didn't start college till I was already old, you know. So let's do this one. Let's see. Number 1 has several problems. It says, for each of the following angles, find the radian measure. Well, that's something to think about. And what are we given? We're given angles in degrees, okay? So let me give you some education about angles that are just generic. So this is not going to solve the problem at the moment, but let's talk about degrees, things you should already know about degrees. Did I spell it right? Yes. Degrees. So if I start, even in geometry, you started with XY plane, and you learned that an angle was created from 2 different rays. One ray would be laying on the x-axis. It's a lazy ray. The other ray is going to be starting at the x-axis, but this one's going to rotate. But before it rotates, that angle has a measure. It's 0 degrees. But once you rotate this lazy ray and it comes out to here, then what you have created is an angle. I'm going to label a symbol because you're going to see it again. The symbol is called theta. Theta is, to me, looks like a little acorn where I make a circle and make another little circle at the top of it. That's called theta. Yeah. And that just stands for, usually it stands for an angle, okay? So what happened when this angle moved this way, that was the positive direction. So that's a positive theta. If your angle was to open the other way, and I hope you saw this in the video, if your angle opened up this way, that would be a negative angle. They may have the same measurement. One may be 25 degrees up and the other one is 25 degrees the other way. It's still 25 degrees, but one will be called negative 25 and the other will be a positive 25. What other fun facts should you already know about angles? If you open it all the way up to the y-axis, it goes all the way up there. That angle has a measure.
90.
Say it again.
90.
Perfect. 90 degrees. And if it keeps opening and goes all the way here, it would double that. And if you're a skateboarder, a 180 is a trick where you flip this skateboard facing this way with a jump and a kick to facing this way. That's called a 180 because it's 180 degrees from the position that it was at. So if you take another 90 and add it, because I'm going back down to this line now, and that would be 270 degrees. And if I go all the way around the circle and end up back where I started, that's another skateboard trick. That's called a 360. But by the way, 0 and 360 are called coterminal. Coterminal means that it may have opened with more angles, but it ended up in the same place as it started. Right, Julio? What's the word? Oh, so close. Coterminal. Coterminal. It's okay. What about 720? Well, 720 means instead of going around once, you went around twice. So that would be another coterminal angle. Is that what you were getting at?
Yeah.
You're right. Here's what he's saying.
What about 1,080?
Oh, you're okay.
Yeah, 1,080.
He's saying that if you draw 0 degrees, it looks like that. If you draw a 360-degree angle, it looks like that. If you draw a 720-degree angle, it looks like that. They all ended at the same place, but yet some rotated.
What about 1,080?
I don't know, maybe. Wake up, Gloria. Don't go to sleep yet. Okay. Now, new word for you, unless you watched the video already. Radians. No, radians.
Where did Ray went? Oh, he went to the restroom.
Radians is another measurement.
Can I go after him?
Possibly.
Reason.
Radians is like compare the English system for measurement, pints, quarts, inches, miles, feet. Compare that to metric system. Millimeter, centimeter, kilogram. No, inches is in the regular. Kilogram, kiloliter, milliliter. Those are all scientifically based, whereas the customary system, the one that the United States refuses to say that we're no longer a customary unit country, the measurement of the foot came from the length of the current king. He had the official foot. So that measurement has been locked into gold, and so everything's based on that king's foot size. So they created, by cutting it up into smaller pieces called inches, and then half an inches, and quarter of an inch, and eighth of an inch. Not even scientific at all. So
it's cool how like your finger lines line up to it though.
it is kind of cool, yes.
You think maybe that had anything to do with it?
I don't know if it did. It could be coincidence, or maybe there was a plan.
What about an inchworm? Is it an inch long?
No, it's not. Anyway, here's what radians measures look like.
Circle.
What a question.
They're angles.
Wait, we're still doing angles, but if I have another lazy ray that's laying on the x-axis, there's two rays there, the measurement that is called 0. Notice there's no symbol. There's not even a word that you have to use, but some people can't resist. They need to say, 0 radians. But typically we don't even use the word radians. We just say 0. And if we were to go straight up north to like the 90 degrees, or we go straight out to the left, that measurement, if I go all the way out here, is pi. The actual numbers, 3.141593 perhaps. I could be off in a digit. But it's pi. We just call it pi. Pi is the exact answer. 3.14 is rounded, so we keep it. So the 90 degrees would have been halfway mark. So what's half of pi?
Half of pi.
Exactly, pi over 2.
Because you can't divide an infinitely long digit.
Well, no, but you could, make it 1.57, perhaps.
Infinitely long numbers.
But it's not exact. And so consider this to be 1 pi over 2. Consider this one to be actually 2 pi's over 2, but the 2's cancel. That would make this one down here how much?
One whole pie.
No,
Oh,
this is the whole pi.
3/2 of pi.
3 pi over 2. And then as you continue, another pi over 2, 4 pi over 2. But that reduces to what? 2 pi.
Ray,
Ray, stop being lazy, Ray. But did you know that it actually extends further because you could go all the way around it, like even more around it?
Yeah, we can keep going. We can keep getting more pi's. You're right.
2 pi and pi like so many
311.
5 pies over pi.
You're absolutely right, Eduardo. So
And keep going and going and going and going until you reach pi over pi over pi.
pi over pi. Oh my gosh. All right. So the question here was to convert these degree measures, just like convert miles into feet, or convert inches into yards. You know, we're going to convert to radians, and I got a trick for you because it's all based on this. Back to this picture here. Let me draw my little sketch.
Pi.
That this is pi, and it's also called 180 degrees. True?
Yes.
So would you agree that those two measurements represent the same thing?
yes.
So what happens is pi over 180 degrees, since they're the same, is equivalent to 1. And if you want to flip it for some purpose, 180 degrees over pi is also equivalent to 1. So I need you to memorize these two fractions because I'm going to use one of those right now. Yeah, really. So here's 140 degrees. Here's how I solve this radians. I take my 140 degrees and to just hold the spot, I put a 1 under it. And I'm going to multiply this by one of those fractions. Which fraction will I pick? Let's see. The one that gets rid of the degree sign.
180. Oh, pi.
Pi over 180 degrees. Since I have degrees in the top and degrees in the bottom, guess what happens to the degree sign? It cancels out. Which I'm glad it canceled because radians does not have a degree sign.
Really?
Really. Radians doesn't have a sign, doesn't have a symbol. At most, we use the word radians. So what am I left with? I'm left with 140 times the pi divided by the 180. And I hope most of you from elementary school learned that, at least 6th grade, that if both end in a 0, you could cancel out the 0. Because that's the same thing as dividing both by a 10.
Or multiplying.
True, you could add a 0. That's right. So I'm left now with 14 pi over 18. Can that reduce any more?
Yes.
How?
Yes, because you could turn 14 into 7 and 18 into. Oh, wait, no, it didn't. No, you can't. 18 is just not.
Yes, you can.
Why not? You're on a roll.
Cut them in half.
Cut them in half.
Oh, yeah, I forget.
Yeah.
It's 7 pi over 9.
So the correct way of looking at it is 7 pi over 9. But mom doesn't have a pi symbol. So when you key in the answer, it literally tells you to use pi. And I tested it out. It works. 7 pi divided by 9.
Yay, we solved the question.
No, we found the answer.
That's what he said, sir. He said, yeah, we solved the question.
Oh, solved the question. I thought he said we found the question.
No,
All right. That did sound silly, but I'm glad it was, but we found the solution. So next one is a negative angle. So remember what negative actually means.
Just the other way.
All it means is that the angle is going the other way. It's going,
other side of the fence, right, sir?
yeah, well, it's actually clockwise. When you go negative angle, that's going clockwise. The regular angle is going counterclockwise. So 270, if you think about it,
It's just actually.
We-
It's 60, 90 degrees.
okay, you want me to move it all the way up to here.
Yeah.
You are absolutely correct, which tells me, Eduardo, that you already understand that negative 270 is coterminal with 90 degrees. You're absolutely telling me the truth, because this would be that they end in the same place. Very good, Eduardo. Now, that was more information than you needed, but Eduardo, he wanted to give some extra to you. So let's do the math again. Here goes. Negative 270 degrees over 1 times the exact same fraction I did in the first one, because I want to get rid of the degrees. So I'm going to put pi on top and the 180 degrees in the bottom. So that way, not only does my 0 cancel, but my degrees cancel.
I'm getting hungry, sir.
Sorry, you have to wait till you get home. Equals to a negative 27 pi over 18. Can anybody see what might go into those two numbers?
6. Okay, this common factor doesn't.
No. Well, how'd you get that?
Because we're all
Divided by
divisible by
3.
3.
Divide by 3. Okay, I'll run with that.
By 3, that's the biggest one.
I'll run with that. Divide by 3, negative 9 pi over 6. Is that done now?
Yes.
Are you sure?
No. I'm getting 3.
That means you could have done a 9 from the very beginning, right?
Yeah, I told you.
So negative 3 pi over 2. Well, that's kind of interesting, because we had our picture earlier that talked about pi's over 2's, remember?
Yes.
So I had my picture over here. This is negative pi over 2. This is negative 2 pi over 2. This is negative 3 pi over 2.
In the assignment,
Say it again.
why did you write the pi?
Because you have to.
Well, down here I wrote it.
You have to write PI.
That's the answer. But up here I'm going to write negative 3 pi divided by 2.
Sir, is it case sensitive?
You can't put the.
You know, I didn't try that.
Oh.
I just tried I just did exactly what it told me. So
Which is what?
I didn't, small p is what it says in the directions. Look at it, had it in quotes. So I don't, I'm a rule follower. So I just did what it told me.
I know how to put pi in the.
I didn't want to be
All I do is use the
a rebel.
or option B.
ASCII codes may not be interpreted, sir.
Watch, I can put pi into
Yeah, I know, sir. It's an ASCII code, but.
keyboard. Wait, that's the floor.
Okay, 160 degrees. May as well do one more here. Let's see. 160 degrees over 1 times pi over 180 degrees. And notice that the 0 cancels and the degree sign cancels, leaving me 16 pi over 18.
Sir, what's this so common?
Well, if you guys are doing your job, you do make my life less stressful, so yes. So 16 over 18 turns into what?
Sir, you should make like ASMR videos.
I don't know what that is.
I don't know.
Do you know what ASMR is?
No.
It's really up there. Sir, I'll show you.
No. Not right now.
See, look, I typed pi right there. See?
I'm waiting for what 16 over 18 turn into.
Divide by 2.
That would be 8 over 9. Is that correct? 8 pi over 9. 8 pi over 9. So I'll leave the last two for you. Let's go on to number 2.
Are we supposed to be taking notes?
Of course you are. That,
Are we gonna upload them?
huh?
Are we gonna upload them?
Not today, because I'm not even sure I'm going to get done with it.
Ignore the rest of
Wait, sir, are you posting them on Twitter?
No,
Like this one?
I'm not posting it yet.
Okay.
My goal is to give you a weekend off. convert the angle 3 pi over 4 from radians to degrees. Well, he didn't even have to tell me it was radians to degrees. Yes, sir. 3 pi over 4. I knew it was radians because I don't see a degree sign with this angle. I don't see a degree sign. I also see a pi. So pi usually implies radians. You looking for the time, Isaiah? 3:22. So here's the work. Here goes.
I got the angle.
I hope it's not contagious. 3 pi over 4
It's literally 4
times, not the same fraction, the reciprocal, because I need it to turn into degrees,
Yes.
right?
Yes.
Malia, what are you working on? Malia, what are you working on? I see on your iPad. So I need my 180 degrees to be in the numerator because I need that to still be there as degrees over pi. Also, if you look carefully, something else happens by dividing by pi. Do you see what else happens right away?
The pi gets moved.
The pi cancels out. Well, wouldn't it make sense if most degree answers don't have a pi unless I make it happen?
Yeah.
It makes sense that I wouldn't see it, but I'm not going to tell you 100% of the time just because you don't see a pi, that means it's radians, because
The answer is
there's a way to write them in decimals and you never know where the pi is. But anyway, so that simplifies it to now. I can't cancel the 0 in the 180 degrees because there's nothing in the bottom to cancel out that 0. So I'm stuck with 3 times 180 degrees all divided by 4. So 3 over 4 doesn't help me, but maybe 180 over 4 does. I think I could divide 180 by 4 in my head.
Yeah.
All you do is cut 180 in half 2 times. That's the same thing as dividing by 4. So what's 180 divided by 2?
90.
So that's 90. So what's 90 divided by 2? 45. So what I'm really looking at is 3 times 45 degrees, because what we just did, I canceled out the 4 and made this into 45 degrees.
So 3 times 45 is 135. I did it way earlier.
That is 135. And they got the word degrees on the outside on this, Mom, so you would be just typing in 135.
Yeah.
Does that make sense?
Yeah.
Or is it clear as mud?
It's clearer than mud, sir.
Clearer than mud. I like to hear that. Number 3. This is actually where your number 3 starts. And I think this problem was thrown at you not to do the work. I think they wanted you to say, convert this angle 360 degrees to radians.
It's literally just 2 pi.
Are you sure?
Yeah.
Yeah, you're right. I thought I could trick you. But that's only my left side of the class. I didn't hear anybody in the right side agree with you. Lincoln was quiet. Gianna's quiet.
Sir, I think you should ask Gianna like the next question.
I get 2 pies.
Sir, I keep sleeping. I can't.
You what? You keep falling asleep. Is that what you said? I didn't really hear you. 2 pi.
Sir, Isaiah's been real quiet since he left.
No.
Who has?
Isaiah has been real quiet since he left.
He's probably asleep. So maybe I'll turn the table on him and make this have to be uploaded before you leave the class.
I know.
Would that be mean?
Yeah.
Ask him.
You should ask him right now, sir.
I don't even know where he is. I don't see him. Stuff's right there. Somebody went to the restroom. I think I heard him say that Kat said he could go first. 4. There's new words in here for you. A sector of a circle has a central angle of 135 degrees. And it wants us to find the area of this sector, and we know for a fact that the radius of the circle is 9 centimeters. So what does this picture actually look like? I think of it as like a piece of pizza. And when you pay for a slice of pizza, you expect that slice to be cut from the center of the circle, cut a slice of pizza. This particular image that I just, with the red and the, I'll make this red too then, around the circle. Whoop, I just erased it. Whoop, can't seem to make a, excuse me. That's called a sector. Sector of a circle. And then the angle that it's inside this by the center is the 135 degree angle.
It's 95.
That's a 135 degree angle. That's the central angle. And FYI, what do I do with sectors? Well, the piece out here that I'll call the pizza crust
You gotta find.
is called an arc. And you can find the arc length if you wanted to, like how much crust is there. And then the sector, you can find the area. How much pizza did I eat? That would be the area of this thing. So there's a formula. There's a formula. The formula is area of a sector.
Which is pi times radius squared.
There's not a pi in the direct look at the moment, but it does become there. What happened? All right, so the correct formula is actually 1/2 of the angle, and then you have your radius squared. Now,
1/2 of an angle radius squared.
Now, there's one little thing that could cause you to get it wrong. This theta must be in radians. And Eduardo, that's where the pi comes in. Okay? So you're really right. There is going to be a pi in there. So my angle is 135 degrees. So I either got to do the conversion right now, or I can ask you, did we already do this conversion? Is it on a previous problem? Please look.
It was on the previous problem.
Then what is 135 degrees in radians?
It's 3 pi over 4.
It is 3 pi over 4. So that's what I'm going to plug in. Here goes. 1/2 times 3 pi over 4 times 9 squared. What's 9 squared? 81. So let's do the math. Hope you're done with that, zoomed out. Equals to 1 times 3 times 81. So let me do the 3 times 81
Hit it. Eddie, hit it, Eddie.
pi, all divided by 8. That's the bottom times the bottom, 2 times 4.
I think you got it in reverse.
Doesn't matter what the order is. I like that better because pi usually goes at the end anyway, Eduardo. So can I do 3 times 81 in my head? Possibly. Anybody? 3 times 81?
Huh? 3 times 81.
We know
That's gonna be like,
we know what 3 times 8 is.
yeah. Well, no.
Yes.
No, I was actually doing like 80 plus 80 would give you 160, and then you add another one, so that's 24.3.
243, that's the answer. 243 pi over 8. And I'm looking at that.
That's divisible.
I don't think it is because the top is odd. So none of the numbers in 8 can go into 243 because you only have a 2 and a 4. and a 6. Those are even numbers. And 8 can't go in because 8 can go into 24, but it can't go into the extra 3. So this is the final answer with our unit, since we were doing area and the radius was 9 centimeters, that would be centimeters squared. So I would just record that answer as 243 pi over 8.
Sir, can you see if that like actually works though? Like if you submit it?
I have tried several of these. Yeah, the PI?
You're supposed to input it a different.
No, like can you like input it?
Oh no, this is a PDF.
Oh.
243 PI, but I did it already at home.
I have selective hearing. It's common in this classroom.
Yep, well, life is made up of choices.
How many questions are there?
I think there's 10.
And it has
All right, does anybody else need to see a degrees to radians done?
no.
No, senor.
How about a radians to degrees?
Sure, why not?
Well, that's the one we've done less of, so we'll do it.
I know that's why I said that.
11 pi over 18 times the magic fraction that has to have the degrees in the top, 180 degrees in top over the pi. And one of the things I noticed is that the pi's do cancel. And if you look carefully, the 18 on the bottom and the 180 on top, there's a relationship. Yeah, how many 18s go into 180?
Like 10.
Exactly 10, not like 10. That turns into 10 degrees. So now I got 11 times 10, nothing left in the denominator. That's 110
Oh.
degrees.
That one was real easy.
It wasn't bad. And the degree word is already on the outside.
They just multiply 11 by 10.
What's that?
I don't know, sir.
Okay.
Oh yeah, you get it.
All right, number 6. Now, get your gloves on because this gets a little trickier. The concept of coterminal angles is probably the least useful for you, but it's part of the lesson 1. Says here, I'm looking for an angle that's between 0 degrees and 360. And at the same time, it is coterminal with another standard position angle that measures 1,873 degrees. So when I say it's coterminal, somehow there's this big angle. Okay, watch me. It can't go around just once. That's only 360. Twice is 720. And then Eduardo was getting some other bigger numbers. It just keeps going around and go around. Eventually, it's going to stop somewhere. And what we're looking for is the angle that's in the standard form would be this angle here. When it stopped. Yes, Kat?
Got it. It's 73.
73 degrees. So what's on?
It is now. Yeah, 357. What?
10 big booms.
337. Sorry.
Oh, I was like, damn, I was going for that.
Yeah, I was going to say the same thing.
We're doing really good. That's why we're excited.
So here we go. We got this big angle of 1873 degrees. So you just have to use your imagination that wherever our starting angle was, it was 37. 337.
I'm gonna put 38.
Okay, dokie. So we got to ask ourselves, how many rotations does that big angle have?
5.
How'd you do that so fast?
Calculator, sir. Yes.
Fine, calculator's fine, but tell me what the process that you did.
I just multiplied 360 by 5 and I get 18.
Yeah, 360 times 5. And you get,
But did you just try 360 times 5 to see?
yeah.
Okay, so 360 degrees times 5, that turns out to be 1800. 1800 degrees. And I only have 1873. So do I have enough left over to do another circle? No. So how many degrees are left?
73.
That has to be the answer.
Yeah.
So if I add to 73, that gives me the 1873 that I had, so that this angle here is only 73 degrees. So you can use your imagination and say that the person opened up the angle here and then just couldn't stop spinning. Spin, 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 spin. But he still stays at the same place. So, 73. But say it again?
Is it journey?
Does that mean I can make degrees infinitely high and it can still be connected with all the other angles?
Yes, you're on something. Next one, number 7.
No, I left.
Well, maybe that's the price we pay.
Sir, you're mean.
I know I am.
What the funk?
We know you are.
I get paid extra to be mean.
That's not fair.
It's called the mean bonus.
Actually,
No.
sir, I get to report you for free too. I'm just kidding, sir.
You know what? Go have at it.
I'm just kidding, sir. You're not rude to me, so I'm chilling.
I'm actually looking for a way to get unemployment.
You want to get unemployed?
I'm looking for a good way out.
Sir, no. Sir, I need you. Sir, I need you. Sir, I
Well, I'll probably stick it out for graduation.
Please.
We're
And then
chicken.
can you come to graduation and then say, fuck it, we ball? And
Hey, watch your language.
I'm sorry. And then say, funk it, we ball? And then,
Sir, how far you after graduation?
If I get a paper copy of invitation, I'll probably go.
wait, a paper copy of,
Yeah,
I'm gonna write it on this.
not that kind. It has to be a real invitation.
Who's graduating?
Almost everybody in here.
I'm graduating. I don't know what the
I'm
fuck y'all talking-
graduating.
Shit, my grades are.
Listen up. Now there's 1, 2, 3, 4 more coterminal problems. Let's do the first one. We're looking at 690. So obviously 690 is not bigger than 720, which is 2 rotations.
Wait, what? Oh, wait, no.
So if I have 690, then I can only take away 360 of it.
Yes,
And the answer of that will be an answer between 0 and 360.
it's 230.
230. So that must be where I end up at. 230.
Wait, what? Sir, it's not 230.
It isn't?
Sir, look at it again.
I was taking his word. It's not.
Oh,
It's 260, isn't it?
330, sir.
No, it can't be.
My bad.
6 minus 3 is 330. What in the world were you doing to me, man?
Yeah, Eddie.
Well, Eduardo's usually right, so I had confidence. Let me erase my evidence over here, though, before I'm embarrassed.
Erase the evidence.
Before I'm laughed out of Harlingen.
All right, there you go.
Get,
Wow, like,
get out of town.
We'll get to it. No, I'm just kidding, sir.
I thought I thought that was 600.
It's okay. I've done worse. 330 degrees.
Okay, let go.
Look at negative 22. Look at negative 22. Somehow, negative 22 is actually down here, right?
Yeah.
Negative 22.
338.
But I need to at least go around one whole turn, though. Or ask myself, what if I went to the right direction instead of going down? What if I went around this way? Let me change the color. This way.
Oh, shit.
So what angle is that going to be? You're absolutely right. 338.
Because you're going the opposite direction.
Exactly. So technically, you're just taking 360 and subtracting this 22-degree angle. Right?
You're always going to go, is it because you always go counterclockwise?
Counterclockwise for a regular positive angle, yes. Clockwise if it's a negative angle.
Wait, that one was a negative side.
Yes, so I did go down clockwise first. But to recreate this, going in the counterclockwise position, I went this way and stopped at the same place. So it's still going to create, if you ask somebody, like you're at a party and you draw this angle and all you do is make a little number 22 degrees here, and you ask them, what angle is this actually? Well, they could tell you, oh, that's going to be a negative 22 degrees. Oh, yeah, you're right. What else could it be? A negative 3, what did you guys say it was? 48? 38? It's also a positive 338. Positive 338 and negative 22 degrees are coterminal. 338. All right. Let's look at number 8.
I'm so hungry.
You guys ever eat lunch?
No, I don't like that.
Well, if you're hungry, you would eat something. There's something in there you can eat.
I eat the sandwiches.
Yeah, the sandwiches are okay, and there's fruit, and there's vegetables. And
Yo, chill out.
number 8, do I need to convert to degrees again? Or convert this negative angle into radians?
Wait, sir, can you go back to 6 and
I guess.
the last one?
You go back to 6 and 7.
Sir, I'm gonna wait a second first. And number
Yeah.
6, please.
You want 6 as well? Why? Where were you? All right. Number 9. Or 8. I was asking, does anybody need those? Either of those done? We have done a lot of those. How about, here's a good one. Write an expression describing all angles that are coterminal with a 48 degrees. Wow. So if you think about it, this is a Eduardo problem. Because if you start with 48 degrees and you say, well, what's the next coterminal in the positive direction? You would have to add 360 to it. So here's my scratch work, 360 plus 48. That looks like 408 degrees. But if I do another one, then I have to do 408 degrees, add it to another 360. That looks like 768?
768, yeah.
768 degrees. But they want all of them. It said all of the angles. Well, obviously, I'm only human, so I can't keep on going forever. I got to stop at some point to eat, right? But a computer program can be programmed to do this. Watch this. I start at my 48, because they said write an expression, so here goes. 48 degrees plus, maybe the degree sign's on the outside, so maybe I don't need the degree sign here.
After that, plus X, after that, parentheses as 30, 360 degrees.
3, 6, okay.
Well, you gotta have a variable.
The variable is going to be K because that's what it said to use. And for common sense, if you're writing a computer program, you need to have something that takes the K and change it to 1, and then change it to 2, and then change it to 3. So we're saying to you that K has to be 1, 2, 3, 4, ... all the way. That means forever. So that's an easy computer program to write. And what you would do is you'd get your screen filling up with angles and angles and angles and angles and angles until you either run out of space on the monitor to see it, or it turns it into scientific notation, or you run out of memory.
Or it turns into a black hole.
Yeah, that's what happens next. Number 10. May as well finish this last one. Obviously, this is radians because I don't see degrees. So here goes. Negative angle 7 pi over 4 multiplied by 180 degrees over pi.
It's exactly the one I saw earlier. All you gotta do.
Cancel, cancel. And somebody already told me what 180 divided by 4 was.
180 divided by 4.
Was how much?
That was 40.
45.
So that's negative 7 times 45 degrees. Whatever that is, that's 280 plus 35. Is it 315?
Let me see.
Negative?
Yeah, this is 4 times that. This is
Or
angle
7 times 5 is 35. Carry the 3, 28, 29, 30. Yep. 315 degrees.
There we go. Negative 315 degrees. Just.
All right. So we're going to call this a wrap. Can you see it, Kat?
Wait,
Wait, I'm waiting.
thank you, sir.
Not a problem. All right, so now you need to open up your canvas and give me 2 minutes to open up what I consider to be the homework, but it's going to close when the bell rings.
Which one?
Let me open it first. I'll read it to you.